Okay, so we are going to work at another past paper. This one being January. So January this year, as you can see, January 2022. Let me turn on my highlights so you can see exactly where I'm pointing. All right. So January 2022, that was the paper that we're going to be looking at right now, so that you can have an idea of what may come on your, June paper. All right. Flowcharts, they are well overdue. And you did get a flowchart to end this exam. So I suggest, guys, pay attention, look at your flowchart symbols again, and so forth. But before we get to the flowcharts, let's tackle question number 1. Remember, all IT papers, paper 2, they are 2 hours. And as you notice, the videos that we're doing, even though we're discussing and we're giving examples and so forth and so on, they rarely take 50 minutes. 39 minutes was 39, 40 minutes, or 40 plus minutes. So even less than an hour. So the truth is you get 60 minutes times 220 minutes. Basically you get at least double to triple the amount of times you actually need to do the exam. So use your time wisely. Again, start always from the back of the paper where you get maximum points. So in case you don't finish, you'd have earned all the major points. All right? So let's start at this question now. Question number 1. Define each of the following terms as it relates to data verification. Data verification, you're verifying something. Think about it. It is basically you, the human being, checking to make sure that the data that is copied or transcribed somewhere else or extrapolated from somewhere matches the data at the original source. So like you're proofreading, what's in your mind, what's in your thought, is that what's on the paper? Looking at 2 documents, one that somebody wrote from another. Is it saying the same thing? That's verifying data. That's normally a human process, human element. Validation is the computerized checking now. Checking to make sure the data is accurate, that it actually makes sense. Example. Let's give an example here. You're going to high school, now you're in grade 11. So if you put your date of birth, let us say, for example, a grade 11 student would have been born, let us say, 2005, not even 5, but 2010, somewhere there. I'm guessing, no, not 2010, but got 2005, yeah? Yeah. You are 17 or so years. So I'm subtracting 17 from this year. You'd have gone down to about where now? Yeah, 2005, 2006, 2007, maybe there, somewhere there. But if you see that your date of birth is the year 2000, that means you're 20 odd years old and you're in grade 11. Or 1990 something. That doesn't make sense. So your date of birth corresponding with your age doesn't match. Not only that, but when you're signing up for email accounts online and it tells you you're too young because your date of birth would have suggested that you're less than 13 years old or something like that. That is simply a check, a data type, not even type check a range check or a limit check, saying that, hey, you're not of the age, you're not old enough. So validation is where the computer is checking based upon the data you entered. All right? So verification, just comparing data copied or data transcribed or transmitted somewhere else to see that it matches the original data from the source. That's normally a human element. Validation is a computer checking up data before it's processed. All right. Outline the function of each of the following validation methods. Give one example of each method. All right. Range check. What can I give one a while ago? Range check suggesting that your age falls within a certain range. It's likely a grade 11 student going to CSEC. Youngest you may find is 14. You may find people a little bit younger than that. Exceptional cases. Extenuating circumstances, I guess. But really brilliant children. But usually 15, 16, 17, 18 for a high school student. That's usually the range. That's an example of a range check. So a range check normally would be between a certain age group. All right. Inconsistency check. Same scenario. You say that you're 17 years old, but yet still you were born the year 2000. That's inconsistent. That doesn't make any sense. All right. It's all in the explanation. All right. You're a senior citizen, but you are born, let us say, 1990. Doesn't add up. You should be at 60 years or more to be a senior citizen. So those are issues that you look at, right, for inconsistency check. The data is not making any sense. All right. You are attending an all-girls school, but your gender is male. You know, those things just don't make sense. All right. And I'm really putting us out there like that, choosing the most obvious way out circumstances. All right. C, the spreadsheet below shows the runs scored, balls faced, and strike rate of each player who contributed to the total score of 199 runs for the Warriors cricket team in a T20 game. The strike rate, this is the part that's important now, you know, these pointers here. The strike rate for each player is calculated as runs scored divided by balls faced multiplied by 100. All right. The percentage, next important point, the percentage of total runs scored by each player is calculated as the runs scored by that player divided by the total runs scored. All right. You can take a look at the spreadsheet, have an idea, see what's going on. All right, let's look at this now. A formula was inserted in cell D3 over here, right, in cell D3, all right, to calculate the strike rate of the player Alfonso, who scored 18 runs and faced 28 balls. This formula was copied to the range of cells D4 to D10. Write the formula which was inserted in cell D3. So remember, it is calculating what? The strike rate, in this case, strike rate. All right, so it is runs scored over balls faced. All right, multiplied by 100. That's what they said. Cool. So that formula would go something like this. Let me put it in here. Let me cut the cell addresses first. All right, good. So look at equal B3 divided by C3 multiplied by 100. Yeah, simple process. All right, let's look back here to make sure our registers are correct still. Let me close this. Having too many windows open. All right, there's B3, the runs that he made over the divided by the balls, among the balls that he scored, that he faced, multiplied by 100. All right, that is the formula. You can put this part in brackets too if you wish. It wouldn't make a difference. But if you want to put them in brackets to say that the division occurs before the multiplication, fine. Still won't make a difference. All right, that should make a difference. All right, but that's the formula right there. Okay, now let us move on to question 3 or 2. Outline what accounted for the result displayed in D9 after copying the formula from D3 to the range of cells in D4 to D10. What happened here? Oh, what happened here was that was no data here. So it gave this particular error. This cell is empty. So it gave a particular error. All right? That's what happened. All right. What else? Question D now. Letter D, state how each of the following types of data is displayed within a cell in an electronic spreadsheet. Numeric data is always right aligned to the right. Alphanumeric or text data is aligned to the left. So let me open a spreadsheet and show you as an example. So you're not taking it by faith because I said so. Let's see, let's put a number here. Let's say 6 to the right. And then put in Joe to the left. So numerical data is aligned to the right of the cell, while text-based data is aligned to the left. All right. Let me keep that open just in case somebody need it. All right, 1 mark each. Continue. Write the formula inserted in cell E3 before it's copied to cells E4 to E10. All right, so E3. All right. So the runs scored by each player now. All right. So Alfonso had 18 runs. Let me make sure. The percentage of total runs scored by each player is calculated as the runs scored by that player divided by the total runs. So the total here is 199. Alfonso scored 18. So it's B3 and B10. So the formula here would use absolute cell addressing. So it would be B3 divided by B10. But what you'd want to do is to make this absolute, because while you can copy downward and you want to change from B3 to B4 for the various players, from B3, which is Alfonso score, to Calendar, there's B4 now, and Ford, that's B5, you don't want it to move from this total of 199. And they did say to multiply by 100 this time. Didn't have to put that this time. Good. All right, cool. So we are perfectly correct. So this is what the formula would look like. Equal B3 divided by $B, $10. And we move on. All right. Next up. State the type of cell referencing used in the formula in each of the following cells. D3, E3. So D3 is relative cell addressing, and E3 is absolute cell addressing. Relative meaning that all the cells can change cell addresses. Absolute meaning that one of the cells also is anchored, is fixed to that location. It cannot move from that particular cell address. 2 marks, and we're moving on. Explain why the type of cell referencing used in F2 is used in cell E3. It is used because, as we said before, like twice already, you don't want to move from one particular cell. While you want the other cell addresses to change, you don't want the cell address that's made absolute to change. We continue. State 2 methods that can be used to prevent members of the public from having physical access to stored information. You can use passwords, firewalls, encryption. Those are just some general ways. All right. It could be that you restrict persons from entering a particular room, biometric scanning devices or something like that. Yeah. To prevent them from accessing certain rooms or certain area where you have equipment with sensitive data. Suggest two software methods now that can be used to prevent unauthorized staff from accessing sensitive data on the network. You can use firewalls, you can use passwords, you can use encryption. Yeah, those are the ones that come right off the top of my head. All right. State two ways in which the integrity of data can be destroyed. All right, data integrity means about keeping data accurate. All right, true. You, by corrupting, by someone maybe overwriting data, deleting a part of it. Those are 2 methods right away. Also because time has elapsed and the data is not being kept up to date. So obsolete information is no longer valid or is no longer has integrity. All right, so those are different ways you can look at. Those are 2 ways. We'll just go to this paper as quickly as possible. All right, because I figured now, guys, that you would be studying and preparing. All right, so there are maybe other ways in which you can look at, but the truth is, we'll also answer the questions just as they are. All right. Sindra has created a web-enabled database application to allow her friends from the university to enter their own data from a web page. The database consists of the following 2 tables, contacts and degrees. Data entered in the gender field must be M for male and F for female. For female, and all dates of birth entered must be prior to the 30th of June 2000. All right, let's look at what they're saying now. Okay. Identify the most appropriate field types for each of the following fields. Date of birth, date and time. Married, let's see what married says now. Married is yes or no. Normally we're used in Access a tick in a box, but that is yes or no, logical field. Degree, oh, degree in this case seems to be a coding. So the degree would be data type text. All right, gender, text as well. But the field size will be set to 1 for gender because you're entering M or F. All right. So let's continue. State what is meant by the term primary key in a database. Primary key means that in this particular field, each record has a unique entry. So bank account numbers, credit card numbers, license plate numbers, TRN, social security, license plate for cars, serial numbers, all of those. It's unique per record. All right. Identify 2 primary keys from the database tables on page 9. Page 9. Okay. Can be listed the page. Oh, page 9. All right. 2 primary keys. Let me see now. ID would be one, and the phone number could be another. All right. It's possible for persons to have the same date of birth, same first name, same last name, and it's a person with the same degree here. Persons can be married or not married. That one be poor. Likewise, gender. So the 2 that are right off the bat, this ID number right here, as well as phone number. All right. Those are the ones I see right away. All right. Outline the role of a foreign key in a database. A foreign key, well, first let's define a foreign key. A foreign key basically means that this particular key might be a primary key from a database somewhere else. All right, let us say the phone number here. This is our ID here for the database that this young lady, Sindra, is using. The phone number can be a primary key, but in a database from the telecom company, from Digicel or Flow or whichever phone company. All right. So this is a foreign key. It did not originate in Sindra's database. It originated from somewhere else. All right. And foreign keys are good because you can use them as primary keys. You can use them as identifier to identify records as well, even if they're not the primary key, because ID here more than likely will be the primary key. But you can use the phone number as well as a primary key, like a candidate key somewhat. All right. But it's good to have. All right. Identify the field or fields from the database mentioned on page 9 that can be used to establish each of the following foreign keys. Contacts. All right. The fields, as we said a while ago, phone number. And degrees. The degrees field. Okay. The degree field. The degree table, sorry. It could be the degree program that exists from somewhere else. The degree code she could create, but the degree program that would come from somewhere else. Foreign key would be like the phone number, as we said. All right. And that satisfies that question. Let's move on to question number 6. Describe the relationship that is used between table 1 and table 2 on the page. Table 1 and table 2. I'm guessing we'll use this here. Table 1, this table. Let me zoom out a bit so we can see a little bit better. All right. So this is table 1 and this is table 2. To create the relationship, you have to use not necessarily the same field name. Degree here, degree code here. But once the field has the same data entered, you can use the code, that particular field. Right, so degree would link to degree code. And because the degree code can be entered more than once, that could, in each table, that could be a many to many. No, this is one. Just entered once here, sorry. That would be a one-to-many relationship because each degree code is entered once here, but will be entered more than once here. So it'll be a one-to-many relationship. I was going to say many to many, but then I realized that the degree here, it's unique per degree program being offered. All right, that's a one-to-many relationship. All right, cool. Let's move on. Question number 3. We're moving really fast today. All right, Roger, a new employee in the information technology department of a supermarket, notices that discounts are being calculated manually. Roger asks for a pseudocode to be generated that would handle 25% discount on merchandise totals. Write the pseudocode for the algorithm that will initialize the variables, prompt the user to input the price and quantity of items, calculate the discount at 25% of the total. If the total is greater than 1800, output the discount amount. Now the discount is a discount amount, not even the amount after discount. Let's get to this now. All right. So let us say this. Let's say as price and total. I set those set to real. Why I say real? Because these are going to actually hold dollar amounts. All right. So you have dollars and cents, so to speak. Let me put discount here. Put discount here as well. All right. So we're going to have price, discount, and total being used to actually hold dollar amounts. So because you have dollars and cents, we will say that is real. Quantity, QTY, set to integer. All right. And get rid of this a bit. Just delete. All right. So initialize, I said. All right, let's do some initializing. So total equal 0. All right, and then now we say, should we prompt the user? Let me check. Go back and check. Should we prompt the user? Does it price discounts? So the code. Prompt the user. All right. So we have to prompt the user. Say print. Print. Enter the price and quantity of an item. And I put read price quantity. Done with that, right? And I said total now is going to be equal to price times quantity, and discount is going to be equal to total. Hold on, I have to do something here. So it's a if total is greater than or equal to 1800, right? So 1800 or more is greater than 18. So I don't have to put equal. All right. So if total is greater than 1800, then it's going to be this. Then let me indent. This is going to be equal to total times 0.25. All right, and then we'll say, let me just go else total, else is a print total, and end if I say print the discount, print discount. So print put it this way. The discount amount is discount. And that is the algorithm. All right. Simple as that. I think I fulfilled all the requirements. Then put start, or put begin, and then put end. That's it. That's our algorithm right there. All right. Now let us continue. Remember, algorithms don't have to run. It's simply a logical thought process for to solve a problem. 10 marks. And that didn't even take us a minute or two to get done. All right. Roger has been tasked with reconfiguring the network system for the supermarket, which is expanding. List 3 types of networks. You have star, ring, bus, or line. You have mesh, you have hierarchical, you have several. All right? Describe one type of network that will be suitable for effectively managing the functions of all departments in the supermarket from a central location. This keyword from a central location is important. You could actually argue, the best one I'm thinking of is a star topology, because ring and bus or line, those have servers, yes, and could do the same, but I think the best one, as far as I'm concerned, is star topology. All right? They didn't ask why. All right? Roger is considering segregating the users of the network. Differentiate between an intranet and an extranet. All right, first things, what is similar? Well, we're differentiating still. Let's see what is similar. Both of them are private. But an intranet is only accessible by persons within the organization. An extranet is also accessible by stakeholders outside the organizations. For example, your customers, your suppliers, and so on. Persons who you allow to connect to certain parts of your network so they can order or they can supply based upon your inventory levels and so forth. So both of them are private, intranet and extranet. It's just that an extranet allows persons from other companies to access specific parts of your network. An intranet is totally private. No one from outside, no one from the public domain can access a network. That's all it really means. Roger must produce a table showing, part D now, the cost of the equipment he will need to purchase in order to facilitate the expansion of the network. The table below illustrates a part of the spreadsheet that was produced. All right, so we have A, B, C, D, regular spreadsheet, and let us get into this now. All right, write the formula to be inserted in cell D5 to calculate the total cost of switches. D5, the total cost of switches, that's easy. D5 is here, switches is here. So I'll be like equal B5 multiplied by C5, right? So we equal so end, zoom this up a bit, equal B5 times C5. That is what that answer would be. All right? Equal B5 times C5. And as we continue, write the function that would be placed in D12 to calculate the average cost. D12 to calculate the average cost. All right, so we're starting at D3 and we're ending at D9. So that formula would look something like this. That function, sorry, bring this up a bit. Equal average, open bracket, D3 colon D10. I think it was D10 it ended. Let me make sure. Yeah, D9 actually. So with D9. All right, so this will be the function. This will be a formula. All right, and let us continue. Roger's employer wants to have the spreadsheet on page 14 sorted in alphabetical order. List in the correct order the steps that will be required to do this. All right. In alphabetical order by what? Let's assume switch here, so these items. So in alphabetical order, let us number this now. So step 1. Oops. Click. Rat problems. All right. Click in the column to be sorted. Now, what is going to happen after you click in the column? You go to the option that says sort icon. So go to the sort icon on the home menu. Then click the icon and choose the sort option. And by choosing sort option, what I really mean is that choose you want to sort ascending or descending. They didn't seem to specify here whether they want the ascending or descending in alphabetical order, right? So alphabetical order means ascending. Then choose the sort option, which basically, let's say sort ascending, right? So we remove that, and then we are done. So that is just where that is. All right, 3 marks, 3 steps. During a staff meeting, management decided that docs were an unnecessary cost. State in the correct order the steps required to delete row 9 from the spreadsheet. You would simply click in that row, all right, docs, click in this row, and then right click, and then select delete, and then choose entire row. Let me go here and give you an example. You could right click here, then choose delete, and select entire row. Or you could simply click on the number here, and then choose right click, and select delete, and it would delete it just the same. Or the other way, the first way, right click, select delete, or delete again, delete, then click entire row, and click delete. Both would work fine, not a problem. All right, let us continue. All right, question number 4. Whoa, we're really running through this. Kiva has just graduated from college with a degree in computer science. She decides to set up a home business offering programming services. List 4 computer hardware devices that Kiva will need to facilitate her business. Working from home to set up a programming business. Well, you want to need four main computer hardware devices. You want to need input devices, output devices, storage devices, and processing devices. The 4 main ones. All right? That's what they're asking you for. Input, process, output, and storage devices. That's what you're going to need. No matter which business. If it's a merchandising business, consultancy business, those are 4 you're going to need right away. Kiva has to ensure that her devices are equipped with sufficient storage. Describe the function of any 2 features of a hard disk. 2 features. All right. Well, to store huge amounts of data, that's usually what a hard disk does, and to be able to access it at good speed, reasonable to fast speeds. Also, to store it permanently. So, store data, store permanently or for a very long time, at good speeds will be 3. And in some cases as well, portability may also be a challenge that you want to work with, especially in the case of external hard drives and so on. All right? Okay. Kiva is aware of some of the threats to a computer system, which may impact the operation of the business. State 1 reason for using passwords. To protect your data. You don't want certain persons to see your data. That's simply what it is. All right, give 1 example of an effective password. 1 example of an effective password that I like to use is this one. I can't use any of mine. So let us say 3, let's use the word 3, and then 1 v 3. And rather than use T, let's use a plus sign. So that could be that is one effective way of your password. So everywhere you have E, you use 3, and F, and you might want to go one capital to make it even more effective. So one of them is capital, one of them is common. So the first one is capital, the second one common, using everything. Capital letters, common letters, numbers, special characters, all of those things are being used, right? So that's an example of an effective password. All right. Kiva writes the pseudocode below for her first client. Study the pseudocode carefully and answer the questions that follow. Set max to 0, initializing max. Enter an integer. Read that integer into a variable called num. While num is not equal to 0, if num is greater than max, which num should be greater than max because max is 0, you can easily punk this program because you can enter negative numbers, all right, and totally mess it up. But let's assume you're entering positive numbers only, all right. So whatever number you entered then becomes max. So if num is greater than max, which is 0, then max becomes that number. And if write the number, write enter integer or 0 to stop. All right. Read num. And then it's an end while, so it ends the while loop, and write max. In other words, write the max. So the purpose of the pseudocode is to get the highest number. Enter a series of numbers until the person enters 0, it will stop, but then it will display the highest number entered. All right. Name the constructs that are in the pseudocode. The constructs are the while loop, line number 4, and line number 5, because they're determining the flow of the program. The loop, the iteration at number 4, the repeating construct, determining how much time the program going to loop in terms of loop until the person enters 0. And if is determining a selection statement, selecting what options or what you're going to do. So line 4 and line 5 are constructs. All right. State the line which represents the initialization. Line number 1 is initialization, because that's the thing. Initialization means at the beginning of a program or the beginning of a loop, you set a variable to a particular value. Could be 0 or 1, whatever one that suits you, depending on what you're writing. All right. Part 4, state the purpose of the second input statement. The purpose of the second input statement is line number 2. That's 1. The second input statement is to, right here, is to get another number. That's all it's really doing. Get another number after you have selected made a selection statement. Is to simply enter number. Write enter integer or 0 to stop. All right, so it's telling you what to enter, a whole number. I'd have put enter positive integer. That's what I would have put there. All right. So it's to get or enter another number. All right. That's what it's doing in the loop while the program is being looped, because this one is not in the loop. Line 2 and 3 is not in the loop. So the person knows every time the program is looping to enter another number. All right. And where else am I now? Part 5. State the names of the variables that are used in the pseudocode on page 17. Name of the variables. Max is one variable. Num is another variable. All right. Those are variables. Max and num. Did I leave out any? Let me check and make sure. Max and num. Those are the variables. All right. And identify the 2 lines in the pseudocode on line 17 that demonstrate relational operators. Relational operators are not equal to, and in this case, greater than. So when I say not equal to, you're looking at 2 elements, and you're trying to determine if they are equal to each other or not equal to each other, as the case may be, like in this case. All right. And this other one at line 5 is evaluating whether it's greater than. So line 4 and line 5, those are the relational operators. All right. And is that it? All right, let's continue downward. Kiva, having written the pseudocode on page 17, wants to use flowchart techniques to show the structure of the program. Draw a flowchart depicting the while loop. Draw a flowchart. Okay, so this is going to take a little bit of time, a little bit of effort. So let me just draw it. We have time. So let me go to a fresh page and use Microsoft Word to create this flowchart. So we can see from the beginning exactly what will happen. Not cutting any shortcuts. So the first thing a flowchart does, insert, I'm going to use these shapes, is that we're going to have an oval. So, oval right away. And this will indicate start. Alright. So, I'm going to edit this. Where is it again? Edit, edit, edit. I need my glasses. Edit. Start. You know what? Let me just do something else here. Shape. I am going to do this. I don't like the shape. I rather it to be like this. Yeah. So, edit the text now. Add text. All right, so I'll put start. This looks small. Let me change the font here. Okay, cool, start. It's a little bit larger. This is going to take a little bit of time. So we start the flow chart and let's continue. Insert. I want another shape, and this is a directional flow, an arrow pointing downward. All right, what else did we do here? Look at this little program here. I'm going to use this program. Set max to 0. All right, enter an integer. Set max to 0. So we have some input statements there. And let's go again. So we're going to have a parallelogram. I should have put on my glasses. Parallelogram, where is it? Parallelogram. Yeah. All right. And I want this one. Yeah. Add text. Max equals 0. I pull this up a bit because I'm going to have space limitations later. All right. And then I'm going to write and read. So let's continue. All right, Control C, Control V. Copy and paste this. Put it here. And can I do this? Control C, Control V. Right, I'll just make this as easy and as short as possible. Guys, please don't kill me for not drawing to scale as needs be. Enter a number. Enter a number. Draw this out a bit. Read num. Print. This is getting all right. Somehow I think I should have put this more toward the middle, but let me see if I need that amount of space later on. I think I'm going to need it, but let me see. All right. So now I say while num is not equal to 0. go back here. So go. Last thing I copied was this. So while num is not equal to 0, going to the rhombus now. Let me find a rhombus here. Really no rhombus? I can't find a rhombus. Let me see. Oh, here's one. Here's a rhombus. And as per usual, I'll go and change this. And then I'm going to add some text. Add text. While num not equal 0. Pull this out. Then I'm going to flow over to yes. Insert, I want an arrow. And my arrow, I want to flow this way. I'm going to draw this out here. Alright. And then I want one of these again to flow downward. Control C, go and copy this and paste it out here. And let me put here I'm going to use a text box and put yes right here. So yes. Okay. So let me continue. What do I do now? If num greater than max, so I'm going to use another rhombus. I'm trying to make this, while I'm here, I'm trying to make this as neat as possible. So if num is greater than max, then what am I going to do? I go and go yes again. Control C, Control V, and carry this one out here. Now when you're drawing flowcharts, guys, your flowchart doesn't have to look exactly like mine. This one looks weird, looks crooked away. See if I can fix this. Looks like a bit crooked. Let me delete this. Insert, I don't like how that line looks. So let me go here. Just draw it out a little bit better. All right. So let me copy this yes. Control C, then Control V again. And I'm going to bring this yes out here. All right. So I'll have a little bit of real estate left. Let me use this wisely. So if it is yes, then I'm going to set max to num. All right. Let me go again. Copy this. Control C, Control V. So I'm going to put num into max. So I'm going to use a parallelogram. Let's go and get a fresh one. Get a fresh parallelogram. All right. Right click, add text. No, max equal num. That's what it said. And I haven't put on space because I'm going to be out of space soon. Alright, so let me do it this way and bring this up a bit. Yeah. Alright, now I'm getting somewhere. Alright, and then I say end of the if statement. Okay, so let me come back here and let me get one of these. Control C, Control V, and bring this to here. Control V again, because I'm going to want this one here. So let me bring this down a bit. I'm really trying to make sure this looks a little bit neat. As neat as I possibly can. And this is just messing up right now. Let's delete this. Let's do a fresh one. So I just can't be bothered with this. Tap here, do a fresh one. Easy that way. Insert line, and I pull from here down to here. Alright. These lines are just getting out of whack. And then I want another line to come from here over to here. Let me come to here. Let me check this and make sure first. And if, and then you're right. I've another input statement to do. Alright. Oops. Alright. So let me get a little circle, a connector. Come on. I could have finished this a long time ago. I'm trying to make this look too neat and too fanciful. Put a little connector here. Hold on a sec. Control. Right. Draw a perfect circle. And then do that. Alright. Now let's continue. I'm going to now output what should be at, I think, line number, let's know, 8 and 9. I'm going to output those and I'm going to end the while loop and then I'm one more output and I'm done. Well, I'm going to regret doing this. Trying to make this thing to look too neat. And it's still not even the way I want it, but let us work with this for the time being. And then output one more parallelogram. Alright, cool. Line 8 and 9. Okay, no shortcuts. At least not too many shortcuts today. Now right click and add text. What am I going to put again? Enter, right enter, integer, 0 to stop. Read num. Alright. So I put right, enter, integer, or 0 to stop. Close quotes. And then, as I've said, read num. Oh, okay. Then I end the while loop. I'm going to end the while loop. I'm going to really do this part here to come over here. No, let me just bring it down here. And then another arrow and bring it over here. Somewhere over here. And bring another arrow from up here all the way down to link up with this here. To look as straight as possible. Alright, cool. And you don't have to put the connectors in. Like the zeros here, you don't have to put them in. I should have, Raptor is a good program to use, but most students will not have access to Raptor, a flowchart program. So I'm using this so that they can try and do it on their own. And then I have one more arrow pointing down, and I will say this is now outside the loop, I think. Yes, after the end while, I say right max. One more parallelogram. Oops. Oh. Insert. Shape. One more parallelogram. And I'll edit. Right click. Add text. Right. Max. Let me change this here to my normal preferred font. And then get this, Control C, Control V, and I am done. All right, get one little oval, and I am through. Thank you, Lord, I'm through. Oh, stop playing with me. Insert here. Let me choose this. No, don't want that shape. Insert. Choose. Yeah, I can choose that one. This one is more akin to the oval that I want. Add text. And then I say stop. And I'm done. So this is the nature of the flowchart that we are trying to do. Not drawn to scale. I'm not the best artist, as you can see. But this is more what we would like to see from our flowchart. Yeah? Let me make this a little bit bigger so we can see the full stop. All right. And I think that should be our last thing, doing the flowchart, and then we are done. Yeah. That is it, guys. So this is the flowchart. All right. Of course, not drawn to scale, not the best I do, but yeah, it could be better. But this is what the flowchart would look like. Your flowchart might look slightly different, but still quite possibly could be correct. So this ends, guys, the January 2022 paper. A little bit of effort on the last one to draw the flowchart, but flowcharts tend to be like that. Take a little bit of effort. All right. So, guys, take care of yourselves. I wish you all the best for your exams. I'll upload this shortly. All right. Take care, everyone. Have a good afternoon.